mynews.studio.
A blue killifish turning up in Kenya, a James Bond lizard found in Jamaica, makes you wonder, are we missing a surge of new life forms on Earth?
Today is January 21st, 2026. For so long, the main headlines have been about extinction and decline. But now, a study from the University of Arizona is flipping that script. More than 16,000 new species are being discovered each year, which is more than ever before. Ellie, does this mean we've really been undercounting Earth's biodiversity all this time?
It certainly points in that direction. For years, the belief was that we were close to finishing the catalog of life on Earth. But these numbers show otherwise. The rate of new discoveries isn't just holding steady, it's actually going up. Just for comparison, about 10 species are thought to go extinct each year. But for every one lost, scientists are describing around 1,600 new ones.
That's a big difference. And these aren't just obscure microbes or rare fungi, right? We're talking about animals and plants people might actually recognize.
Exactly. In 2025, for example, the Natural History Museum described more than 260 new species, covering insects, fish, reptiles, and even fossils. Ocean Census turned up 866 new marine species in under 2 years. That list includes things like a pygmy pipe horse and a guitar shark. Over at the American Museum of Natural History, they found a feathered dinosaur and a mouse opossum in Peru's cloud forests. Every single discovery adds to the idea that Earth's diversity is much greater than we thought.
How are scientists managing to find so many new species so quickly? Is it just more people in the field? Or is technology playing the bigger role here?
Technology is actually a huge part of it. Genetic sequencing, for example, lets researchers tell apart species that look virtually identical but are genetically distinct. High-resolution cameras and underwater tech open up places like deep ocean trenches or the tops of rainforests. Ocean Census, for instance, used DNA analysis and artificial intelligence to identify over 800 marine species in less than 2 years. Without those tools, many would still be unknown.
So the tools are getting better, but the sense of urgency isn't going away. A lot of these new species are already at risk, aren't they? What are the main challenges when it comes to both cataloging and protecting them, especially in places that are hard to reach?
Cataloging a new species isn't fast. It might take years of DNA work, comparing physical features and publishing the results. When it comes to protection, habitat loss, invasive species, and climate change are the main threats. Take the Caribbean. More than half of the 35 new lizard species found there may already be threatened, and some might be gone before we even get to study them. In Peru, researchers have to do night hikes just to collect enough data on rare frogs. And in the oceans, it's even tougher. About 10% of marine species are known, so most don't have any protections in place at all.
And it's not just about scientists from outside coming in. A lot of these species are already familiar to local and indigenous communities. How does including indigenous knowledge and international cooperation change the picture?
It makes a significant difference. Projects like Ocean Census bring together researchers from multiple countries, which speeds up discovery and confirmation. When local researchers take the lead, the work becomes more focused and meaningful. And indigenous knowledge is essential. Local names and detailed knowledge about where to find species, like Peru's mouse opossum, have guided scientists to new discoveries. Combining scientific and traditional knowledge helps identify which areas are most important to protect, both for science and for local culture.
That brings up another point. Why does this matter beyond just learning new facts? Do these discoveries have any practical benefits?
They can, yes. Many species have unique traits that inspire new technologies. Gecko feet, for example, have inspired advances in climbing equipment. Some plants or animals could become sources for new medicines. As John Weens from the University of Arizona said, we're only beginning to understand what these species might offer us.
Just to put this in perspective, 15% of all known species have been described in the last 20 years. Would it be fair to call this a golden age of discovery?
That's exactly what the data suggests. The focus is starting to shift, not only worrying about what's disappearing, but realizing there's still so much left to find. The real challenge now is whether we can discover and protect these species before it's too late.
So, to sum it up, Earth's biodiversity is far from fully cataloged. The rate of discovery is leaving extinction rates far behind. Technology and local expertise are speeding things up, but many new species are at risk from the start. The next step is to map out key areas and make sure everyone's voice is heard in the process.
Every species we find is both a scientific discovery and a chance to protect something unique. The first step in conservation is simply knowing what's out there.
Thanks for joining us as we explored the lesser-known corners of Earth's biodiversity and what they mean for science and conservation.
Thank you for tuning in. This episode was brought to you by mynews.studio. Try it today for free.